Imagine writing a program that works perfectly, only for a simple math error, like dividing by zero, to violently crash the entire application. Before writing any code, verify your setup. You will need the Java Development Kit installed, a text editor ready, and an active command prompt. Working through these two procedures establishes a foundation for building code that remains stable when faced with unexpected inputs. Step 1 is setting up our directory. Create a new master root folder on your computer. Inside that root folder, create a specific subfolder and name it exactly My Package. Now, inside that My Package subfolder, create a new Java file called greeting.java. To officially register this file to the folder's namespace, the very first line of your code must declare the package. Simply type package, my package at the top. Next, we need a file to actually run the program. Go back up to your root folder, outside of the package directory, and create a file named mainclass.java. Close attention to your capitalization here. Java is strictly case-sensitive, so my package must match exactly between your folder name, your package declaration, and your import statement. By structuring files this way, packages act as organized containers. This allows us to group related classes together and prevents name conflicts with other libraries we might use. With the files written, it is time to compile. Open your terminal at the root directory. Do not open it inside the My Package folder, or the compiler will lose track of the correct file paths. You must compile the files in sequence. First, compile the package file by typing java mypackage/greeting.java. Then compile the main class, java mainclass.java. Finally, run it with java main class. If correct, the terminal returns the successful "Hello from the package" message. These pathing commands provide the instructions the compiler needs to bridge the gap between separate directories. A divide by zero scenario, we wrap our math logic inside a try block. If the math fails, the program immediately drops down to the catch block for an arithmetic exception, where we print a safe warning instead of crashing. We apply this exact same logic 2 more times. We add a second try catch for a number format exception to catch letters typed in place of numbers, and a third for an array index out of bounds exception to catch invalid list requests. Catch block acts as a safety net. It intercepts specific errors and reroutes them so the application can finish its execution safely. Let's put this logic to the test. Compile the file and execute it in the terminal. First, we intentionally divide 10 by 0. The program intercepts the math error, printing our custom warning. Next, we type letters A, B, C. The number format exception catches it immediately. Finally, asking for an invalid array index triggers the out-of-bounds block, keeping the program stable. Inputs that normally cause immediate crashes now result in polite, controlled, user-facing error messages. Implementing this hierarchy ensures that classes are isolated within their own namespace, allowing you to manage and organize related code as your projects grow in size. Likewise, exception handling provides a mechanism for managing unpredictable operations, whether reading a file, connecting to a network, or processing user input. Developing code that can intercept and respond to its own failures ensures the application continues to run despite the unpredictability of real-world use.